Welcome back, learners, and welcome to our lessons in General Physics 1. Now, today we are going to learn about performing addition of vectors. So, before we start with our lesson proper, we are going to see the learning objectives for this lesson, okay? So, after finishing the module, you should able to first enumerate the methods of vector addition. Second, understand the steps in polygon and parallelogram methods of vector addition. And third, perform addition of vectors using polygon and parallelogram methods. So let's begin. So consider the figure on the right. A, B, and C are displacement vectors of the different points. D is another vector which is the net displacement. The displacement will tell the distance and the direction of the final position from your initial position. So, the question is, how can you determine the magnitude and direction of D? Okay? So, upon seeing that illustration, you can see that you have traveled from school to store 22 meters. The distance from store to your classmate's house is 12 meters. And you went to your home 10 meters away. Now, the net displacement from school to home is the question. So, what is the displacement from school to home? So, let's proceed. So, the net displacement can be determined by the addition of vectors. Okay? So, when we say addition, we are going to use or get the vector sum of A, B, and C. That will give us the net displacement, which is letter D. So, if we are going to add A, B, and C, what do you think will be our final answer? So, we can get 44 meters if we add A, B, and C. Then, the vector sum of any vector quantity is also called as the resultant force or the resultant rather. So now, how is this related to the net displacement? How is resultant related to the net displacement from school to home? So, in performing addition of vectors, we have two methods. These are the graphical method that includes polygon head-to-tail method or parallelogram method. We have also the component method. Okay? So let's talk about the graphical method in the polygon method. So, use the polygon and parallelogram method of vector addition to find the resultant C of the vectors A and B. So the given value for the vector A is 300 meter east and the given value for the vector B is 400 meter north. So let's see. So first step in polygon head-tail method is you have to choose an appropriate scale to plot the vectors. But before that, let us see the given values, which is A is equal to 300 meter east and B is equal to 400 meter north. Now, our formula would be C is equal to the sum of A and B. So let's go back with our first method. So we have number 1, which is to choose an appropriate scale to plot the vectors. Example of that is the scale of 1 centimeter is to 1 kilometer. You can also use 1 meter is to 1 mile. So let's continue. The second step or process is you have to draw the first vector with appropriate magnitude and direction. So take note, what is our first vector? So our first vector is A, right? So what is the direction of our vector A? So it is 300 meter to the east. So let's plot it in our Cartesian coordinate plane. Now, as you can see, it follows the axis because the x-axis goes to the east, or it directs to the east. So, take note, class, that the magnitude is represented by the length while the direction is represented by the arrowhead, and that was discussed before. Now, let's proceed to the third step. Now, draw the tail of the second vector to the head of the first vector. So, upon plotting the first vector, which is 300 meter east, then the next thing that you have to do is to draw the second vector into the head of the first vector. So the red one, or the red arrow, denotes the first vector, and the blue arrow denotes the second vector. So now let's consider the direction of the second vector. So the second vector's direction is 400 meter to the north. So it follows the y-axis. So for every succeeding vectors, draw the tail of each to the head of the preceding vector. So that is the principle of the polygon or head to tail method. So let's continue. Number 4, or the fourth step, would be draw the resultant vector from the initial point or tail of the first vector going to the final or head of the last vector. So if it only the given values are A to B, then you could stop there, then draw the last or the resultant vector from the tail of the first vector going to the head of the last vector in order for you to see the resultant vector. So as you can see in the illustration, red is our first vector, blue arrow is our second vector or the B vector, and the resultant vector would be the orange one, or the orange arrow that connects the tail of the first vector and the head of the last vector. So now measure the length and the angle with respect to the x-axis of the resultant to determine its magnitude and direction. So basically, as you can see, what is the direction of the orange arrow? So it is going to the what? It is going to northwest. Okay, so it goes to the northwest. But if you can use protractor or measure any measuring device in order for you to define the angle of that, you could see that it is 53 degrees. So that is how you see or determine the magnitude and the direction of the resultant vector. So that is for the head to tail method. Now let's discuss about the parallelogram method. So the parallelogram method has similar with the first step in the head to tail method. So number 1 would be choose an appropriate scale to plot the vector. So the example of that is the scale of 1 centimeter to 1 kilometer. So as I've mentioned a while back, you could always use or the scale what would be you could use your own scale, just put or use an appropriate scale. So second one is to draw the first vector and the second vector from the origin or the same origin with appropriate magnitudes and direction. So the magnitudes of the A vector or the first vector goes to the x-axis. Okay? The magnitude for the B vector would be, it goes to the y-axis. So as we follow this instruction, we have to draw the first and second vector from the same origin with appropriate magnitudes and direction. So since B, the direction of B or the second vector goes to north, you can use the y-axis to denote letter B or second vector. You can use the x-axis to denote the direction of the first vector. So third one will be, draw another set of vectors that are parallel to what you have drawn to make parallelogram. So you can see the figure there that we have made a parallelogram, right? So how is this related with each other? Now, draw a diagonal draw a diagonal from the origin, and this is now the resultant vector. So how do you define or differentiate the first method from our second method? So basically, they are just similar, but in the parallelogram, you just have to make a parallelogram structure or illustration. So that is how we identify the resultant vector from the given values or from the given data. Okay? Last, measure the length and the angle with respect to the x-axis of the resultant to determine its magnitude and direction. So it's very easy. It's just basically plotting it to the Cartesian coordinate plane with respect to the measurement and the uh, what do you call this, with respect to the measurement or the magnitude and the direction. So this is the illustration of how, if you will try to add more vectors in that specific problem. Okay, so remember, in polygon method, the resultant is determined by the connecting the vector in the head to tail manner. The resultant is drawn from the initial point to the final point. Next, in the parallelogram method, the resultant is drawn from the origin after the parallelogram is constructed from the vector. So it's basically similar, but I think the first method is easier to do, right? So that would be all. That ends my presentation, and thank you very much.